So in the following example, we are looking at a sine being equated to a cosine. Now remember that these cofunction identities over here are what we're going to be using in order to solve this kind of a problem. Right now, it looks pretty challenging, but when we use and apply one of these cofunction identities, it's actually going to be a piece of cake. So what I'm going to do is I'm going to take a look at these, and I know I'm working with sine and cosine over here. So I'm going to find one that relates sine to cosine. All right. And I think what I'm going to do is just going to use this very first one right here. Right there. Sine equals cosine of 90 minus theta. So sine of theta equals 90 minus theta. So I'm going to write that off here to the side. I'm going to say that the sine of theta equals the cosine of 90 minus theta. Now what I'm going to do here is I'm going to kind of make a substitution. And I'm going to say, and I'm going to pretend that this right here, sine of 3 theta minus 17, is going to be, this 3 theta here is going to be my theta. All right, and it's really not theta, the same theta here. So, you know, because it's in a different color, we'll assume it's something different. But we're going to take all of this and we're going to call it theta. And actually, let's just call it, theta prime. Okay, let's call it theta prime. Let's not call it theta. All right, but what I'm going to do is I'm going to say, well, this should equal the cosine, right? The cosine of 90 minus this green thing that we call theta prime. And actually, let me erase that. Wrong color. There we go. And we're going to close that off. So I'm going to go back and I'm going to make that substitution again. So I'm going to say, well, this is the cosine of 90 minus, and I'm going to say 3 theta minus 17. So something that looks like that. And now I'm going to equate it. I'm going to set it equal to the cosine of theta plus 43. Okay. So the hardest part has already been done. Now we just do a little bit of simple distribution here. And we're going to say, well, this is the cosine of 90, take away 3 theta. And then negative and a negative is positive, so plus 17. And that's still going to be equal to the cosine of theta plus 43. That hasn't changed, so this comes straight down and follows. All right, now we're going to combine some like terms on the inside here. And we're going to say, well, the only thing that we can combine here is this 90 and this 17 because they're digits and they don't have this variable theta tagged to them. So this will be the cosine then. 90 and 17 makes for 107 degrees minus 3 theta, and set that equal to the cosine of theta plus 43. So look, something like that. And then what we're going to do here is, because these are both cosines, okay, we can just drop it because now we have two cosines that are equal to each other. All we have to do now is solve a very elementary equation, and that is to set this thing right here equal to this thing right here, and then we are done. So we're going to say 107 degrees minus 3 theta will equal theta plus 43 degrees. All right. Now, how you go about solving that equation is completely up to you. I am going to do this all in one step. So I'm going to add 3 theta. I'm going to add 3 theta so that this right here cancels out. And then I'm going to move this over, subtract 43 degrees, subtract 43 degrees so that this cancels out right here. And I now have 107 minus 43, which is 64. And I am going to set it equal to 4 theta. And then I simply divide by 4. Simply divide by 4. So theta will equal 64 divided by 4, which is 16 degrees. And you can go ahead and you can substitute that into the original sine and cosine functions that you have there, and you will see that it actually works out in terms of the cofunction. So we have solved this. So theta here for this problem anyways equals 16 degrees. Sorry about that one. So good luck with this.